To start off, we're going to go through interior-exterior angle sums and interior-exterior angles for regular polygons. We're first going to look at one that has 3 sides, and of course that is called a triangle. And a triangle, we've learned in a previous chapter that a triangle has 180 degrees for its interior sum. Therefore, for a regular triangle, which means all the angles are equal, each interior angle measure would be 180 divided by 3 angles, so 60 degrees would be the interior angle measure for each angle. The exterior angle sum is always 360 for every polygon, because it takes 360 degrees to go around a shape. So 360 here. We might as well just put it in for the others, since it's always going to be 360. And I usually like to start with exterior angle sum, just for the fact that exterior angle sum, you divide by 3 again, because there's 3 exterior angles. You can find out that is 120. So each exterior angle will be 120, and then the exterior angle and the interior angle have to be supplementary, which means they have to add up to be 180. So 120 and 80, or 120 and 60 adds to be 180. We can do this as well for a 5-sided polygon, which we call a pentagon. Here, the interior angle sum, we can start off by picking a vertex and then connecting and drawing some diagonals. So here's one triangle, so 180 degrees. Draw another triangle from that same vertex, 180 degrees. And a third triangle is up there, 180 degrees. 180 times 3 is 540 degrees. And notice the number of sides, there's 5 sides, and there was 3 triangles. For the triangle, there's 3 sides and 1 triangle. So it's always 2 less than the number of sides. That's how many triangles there would be. The exterior angle measure then would be 360 divided by 5. So 360 divided by 5 is 72 degrees. And here, just going back way, what is supplement to 72? And that is 108. Again, supplement means what adds to give me 180. So 108 and 72 add to give me 180. We can do the same for an octagon. In an octagon, if we go by that same, subtract 2 from the number of sides, and that's how many triangles there are, we will end up with 1, 2, 3, 4, 5, 6. So 8 minus 2, we get 6 triangles. Again, just like we have there, 6 triangles. 6 times 180 is 1,080 degrees. And we can divide that one. We can go either way, so you can pick your method. I'll just show the first way again. We can take the interior angle sum, divide by 8, because there's 8 interior angles, and we will end up getting 135 degrees. Each exterior angle measure then would be supplementary to that, so that would be 45. And you can find that as well, because 360 divided by 8 is 45. And that is pretty much it with finding those. We could start, you could say, just do a general case. So let's say there's n sides. So we don't know the number. This would go for any situation. Then the interior angle sum would be the number of triangles, which is n minus 2. And we'll take that times 180. The exterior angle sum, again, is always 360. The name of the polygon, we'll call it an n-gon. Each exterior angle measure is 360 degrees divided by n, the number of angles and the number of sides, which will be the same. And each interior angle measure is the one that looks probably the most complicated. We're going to take the interior angle sum, so n minus 2 times 180, and we're going to divide by n the number of sides or the number of angles.